Hey guys, welcome to my YouTube channel. I'll be solving LeetCode 75 list using Golang. So let's look at today's question. Maximum number of vowels in a substring of a given length. So given a string S and an integer k, return the maximum number of vowel letters in any substring of S with length k. And vowels are A, E, I, O and U. Okay. So let's just look into an example. So basically the question states given a string s and k, you need to consider each substring of length k and see how many vowels it has, and you need to return the maximum number of vowels that is present in a substring of length k. So basically, if you look at this string, go and check every substring of length k. So basically consider this ABC. How many vowels are there? Vowels are A, E, I, O, U. In this case, A is the only vowel. So currently only one. So rest is equal to 1. And then keep moving. BCI. I is the only vowel, so rest won't get updated. BCI. So there are, sorry, CII. So basically there are two I's. So rest gets updated and then keep moving. You have I. So there are three I's in this window. So rest gets updated to 3. So you can keep doing this to every single you can keep increasing the window and keep the size as 3 and keep checking, and you can see what's the length is and keep updating the maximum length. So there are a couple of ways of solving this. So I'll just tell you the brute force so you get an idea of how you can solve it yourself. So brute force is just consider all substrings of length k and count number of vowels in that substring, and finally update global result. Okay, this is how you would do it if you do it in a brute force way, and doing it in a brute force would cost you O of n square time complexity, because the way you would traverse all the possible substrings are something like for I is equal to 0 to n, for j is equal to I plus 1 to n. So you will basically have a nested loop to find all possible substring. So that's why a brute force solution will cost you O of n square. So that is very inefficient. I won't be solving it using that, but it's a very good first starting step to think about the solution. So the solution I will be employing is something called sliding window. So currently we are solving all the problems of sliding window technique. So the way this sliding window works is, so if you have a string like A, B, C, I, D, E, F, and k is equal to 3. So first we'll consider a window. We call this a window of size 3. Okay, because k is equal to 3. And we will count how many vowels are there. One vowel is there. We'll update it. And then we'll move our window. So increase our window. Now the size of the window became 4 because A, B, C, I. So decrement the previous L. So the boundaries you can call it L and R. So as soon as you increment R, you need to also increment L because size can only be 3. So increment L. So current window is BCI. Now count how many vowels. BCI also has just one vowel. Do the same thing. Increment your R, decrement your L. So CII has two vowels, update your res as 2. So keep doing this, increment your window and shrink, increment the end of your window, basically increment the end of your window and shrink the beginning of the window, because we need to maintain the size of k is equal to 3. So keep doing this, and once you keep doing this, you will arrive at this window where L is here, R is here, and the substring is I. So let me write it in a different color. So you will arrive at the window I. So this window basically has a res of 3. So res will be 3. So global res 3, this will be the maximum. So even after that, you keep extending your window and sort of decrementing the beginning of the window. Basically, even if you keep sliding your window, the maximum uh, res is only 3, because there is no other substring which has 3 vowels. So the vowel with maximum, the substring with maximum vowel is I, which has like 3 vowels, 3 vowels, so res will be 3. So basically this is the technique, sliding window, which we will be using. So again, let me just give you a brief overview of how sliding window works. So basically, given any substring, so let's consider a substring as xxxx. So this is any, it can be any possible characters, and given any some k which is equal to y, you think. Okay, so given something like this, the way sliding window works is, initially we will take a window of size k, y, which is given here. Okay, and then we just keep sliding it. R will come here, L will come here, R will come here, L will come here. Keep sliding it till the end. And then what they would have in the problem, they would have given you some objective. Do just do that objective. In this problem, what is the objective? Find max count of vowels. So that is the objective of this problem. So move the window, basically slide the window and do the objective. That depends on the problem. So that's it. And the time complexity of this approach would be O of n. Now I'll go back to the editor and write the code and sort of show you how we can implement this in Go. So for doing this, initially we need a set, basically a set, but Go doesn't have a set. So I will show you how we can sort of get a set sort of implementation in Go. So initialize a set. So call it vowels. I'll explain it to you what I'm doing here. Map type is byte, value is bool, and yeah, a, list down all the vowels, a, e, sorry, I, o, u. So we list down all the vowels and then basic sliding window. Okay, first let me explain it to you why I did it like this. So basically Go doesn't have a set data structure. So basically if you're used to Python or something, you have something like set. So in Python, if I had to do this, I would have done something like a, e. If you are coming from Python, you would understand it. You would define a set like this, and lookup to a set is O of 1. But in Go there is no set. So what I'm doing is, but Go has a hash map. So I'm defining a hash map with key as the character. So character as a type of byte and the value as bool. So I will explain it to you why the value is bool in a second. once I do the remaining code, you will understand why it is bool. So let's define the initial window. So let's have a count as 0. Count represents number of vowels. Number of vowels in current window. So I is equal to 0, I is less than n. So initially we are moving to our very first window of size k. Okay, so if vowels of s of I, then count plus plus. So now what I did here, vowels of s of I. So vowels of s of I is what? Vowels of, suppose our s of I initially is a. Okay, so it will check vowels of a, which is true. So basically this hash map is telling whether the character s of I is a vowel or not. So if it is a vowel, we are incrementing the count. That's why I created an hash map which looks of this type, where the key is character and the value is a bool. So now we processed our first window. Now we will process remaining of the window. I is equal to k, I less than len of s, I plus plus. So as I told you, we will extend the r and we will we will shrink the l. So that's what I explained it to you. So let me define my l and r. So l will be I minus k at the beginning of the window. R will be I, which is the end of the window. So 2 pointers pointing one. L is pointing at the beginning of the window. R is pointing at the end of the window. And now what do I do? If vowels of R, if it is a vowel, basically vowel of S of R, if it is a vowel, then increment count. And even before that, we need to initialize our res. So after the first window, maximum number of vowels will be equal to count. So we will initialize our res to count initially, because after the first iteration, basically after seeing the first window, our res value is count. Okay, now what we will do, and also this initialization should be like this. And okay, I think should it be like this. Okay, now if vowels of s of l, if the beginning of the previous window, if that was a vowel, shrink, we are shrinking it. So count also you should decrement, because we are shrinking the window, decrement the count. And if the final count, if the count of that particular window is greater than the global result, reinitialize the rest to the count, and we just have to return the result. I hope you understood the code. Define the boundaries of the window L and R, and then keep extending R as I mentioned. If it is over, increment it, and keep incrementing the L also, because the window is sort of sliding as I showed in the diagram. So once you are doing it, if it is a vowel, you need to decrement it, because you just got rid of that S of L. So that character is no longer in the current window, so you need to decrement the count. And if the count of the new window, is greater than global count, increment res, which is the global count. Now we are returning it. Run it, submit it. Okay, gets accepted. What is the time and space? Time is O of n, because there is just one loop. Space is also O of 1 actually. Why O of 1? Because vowels only consists of A, E, I, O, U, which is always constant. The space is O of 1. and time is so often. Thank you so much for watching my YouTube video. Please subscribe.